15. State which of the following species are amphiprotic and write chemical equations illustrating the amphiprotic character of the species. And then we have letter D. So the question is, can NH4 plus exist as an amphiprotic species, or can it be amphiprotic? Well, another word for amphiprotic that your teacher or professor might use is amphoteric. So amphoteric, amphiprotic, tomato, tomato. This just means that a certain ion or a molecule can act as an acid sometimes, and it can act as a base. Just depends on the situation, exist. But the key thing is that your ion can act as an acid and a base. It has both properties. So, let's see. Well, what constitutes as something as an acid? This is Bronsted-Lowry. So Bronsted-Lowry says that acids will always lose one H plus, or just a hydronium ion, right? A hydrogen. So if you're going to lose something, if you're going to donate a hydronium ion, you got to have an H to begin with. So I'm looking at NH4. Here is a hydrogen. I got 4 of them. So yeah, at least one of them are going to be acidic, right? And the ammonium ion can lose one of the hydrogens. It can donate it to a certain base that's in solution. So that's all cool. This one can act as an acid. Now let's see if it can act as a base. Well, a base is a little bit harder to figure out. Bases rely on their charges to tell you if they're going to be a base or not. Generally, bases are going to be negative charges or neutral. Now, in this case, the charge of ammonium is a plus charge. It's a positive, right? So, since bases are generally negative charges or neutral, this one is a positive. Positives are acidic. That's like an indication that it could be acidic. But positives, very rarely would they act as a base. Now, in order to really see what's going on here, let's just write out the Lewis structure. That was in a previous chapter, so we should know how to write a Lewis structure. So I'm just going to write it here. We have nitrogen surrounded by 4 hydrogens, and they're all single bonds, right? And if we just wanted to show the charge, you would just have to put this in brackets and call it a positive up top here, right? Now, remember, the Octet Rule. Nitrogen only wants to have 8 total electrons. In this case, it does. 2, 4, 6, 8. Now, if it's acting as a base, that means that it's going to accept a hydrogen, gain 1 hydrogen. So that means that all these 4 hydrogens have to stay, but the nitrogen has to be able somehow to gain another hydrogen. And if that's the case, this nitrogen has 2, 4, 6, 8, 10 electrons. That's way too many. So it's not possible for this nitrogen to accept or gain another hydrogen bound to it. All right? So this one, can it be a base? No. And because that's the case, this is not amphiprotic or not amphoteric. It has acidic properties, but it cannot act as a base. And that's it. Hope this helped. Let me know in the comments. Thank you so much for viewing the video. Subscribe to the channel. That will help us out tremendously. And I hope that you guys are doing well out there. Let's keep studying hard, and I'll see you in later lessons. Bye-bye.